All right. Welcome on the podcast, Gustavo Vargas. I hope all is well. Would you like to describe yourself, who you are, in a few sentences?
Yeah, first of all, thank you so much a lot for letting me be here. It's a pleasure. I'm Gustavo Vargas. I'm 34 years old. I'm from Peru. I'm living in Spain like almost all my life, 20 years I think. I'm a building engineer. Um, have a master in data science, and I'm finishing now my second undergrad. This time in economics. I have worked in a financial AI research department. Um, then I changed to work as a software developer in consulting. We were using LNP, but also all the DevOps stuff there.
Hmm.
And now I'm working as a data scientist, and I take care of the full end-to-end pipeline for my project. So different needs, different paces. Well, it's been
Yeah.
fun.
Awesome. Well, I feel like I'm looking forward. I was very looking forward to this episode because you have a very interesting background and you've been working in the field for a while. I might go directly for my first question. You've mentioned that you've been doing research. You've also been doing consulting software development and consulting technology. Could you share about the differences that you faced between these three fields?
Yeah. Um, well, in my first job, in research, what you need to do is to create a base technology that can
Mm-hmm.
be used to create other products and that in turn can be used by clients. Well, beforehand, you don't really know what's going on, what's going to go right, or what's going to go wrong.
Mm-hmm.
But you have to read a lot of state-of-the-art papers. And in my case, of course, I gave preference to literature that was accompanied by code, even if I had to redo it later. Thanks to luck, I had there a mentor that gave me a lot of, well, teach me a lot, and that was great to be there. We have this we made these private papers and try to make a product in the end. So in the world of software development in consulting, it's mostly software development, right? What I was doing was developing code for some product. Um, the pace was quite different because
Mm-hmm.
you work with these 2 week sprints, reviews. You have to develop, test, deploy in pre-production, test again, merge your
Mm.
code, and deploy again in production. Well,
Yes.
the culture is focused on delivering, mostly preventing large-scale failures.
Mm.
The typical not deploy on Friday meme was really a good thing to know. Okay, now I'm working in technology consulting firm where the focus is on the client and the product that is needed. So pace is slower, good quality is required. So it's kind of different. The different deadlines and different budgets creates a different work environment,
Mm.
different practices and different habits.
Mm.
The I could say that the management style matters, but it's constrained by these other limitations.
Yes.
And well, there are differences, and that matters. But I think for me the deadlines matter the most, and that creates the way you are going to behave with your partners or your coworkers is going to be different.
All right. Thanks a lot for sharing. It's not every day is like we can have the um, the perspective like from going to research to software development and consulting to technology. So if I'm not wrong, while you were doing research, you've worked a lot with time series. Could you tell me more into could you get me more into this subject? Could
Yeah.
you tell me more?
Um, I was on a financial advisory company, so we
Mm-hmm.
did it with time series because we wanted to make products that were using time series. Actually, financial time series.
Mm-hmm.
In the machine learning world, when we began to learn these kind of things, these algorithms, we began just with tabular data problem for regression or classification, and
Mm-hmm.
eventually, you jump when using neural networks to text data or images or video. But well, perhaps in the way in this way you are having teach about time series, and perhaps not. Perhaps just I don't know recommendation systems or so on. In time series, we have a lot of data problems where we can assume some time dependency. That is, when a single data point depends of the previous values.
Yes.
We can ask ourselves if there is a pattern in the series, if we can, if perhaps a model can predict the series using previous values,
Hmm.
perhaps I don't know. I can predict what your breakfast for tomorrow using the data of your breakfast in the previous days. Perhaps there's gonna be some error, but uh, with some great probability, I could be certain. Or for example, if a certain day is a holiday or is a weekend, I can expect
Hmm.
to have more people in restaurants, which gonna be a bet an increase in restaurants demand or electricity or transportation. You know, time dependency is almost in a lot of problems that we need to in prediction, and we are not able to use a direct um, tabular data. It's not a classification or regression directly. So well, we need to approach the problem from a different point of view.
All right, thanks. I really enjoyed also the way of you capturing like the different applications of time series, and like where we can bring value. I would like to get into like even more deeper into a time series. So, what are the models used in machine learning and statistics regarding time series?
Okay. Well, I will separate, this at first. The first group perhaps is this classical statistical models. Perhaps they don't. Perhaps a statistical guy will not have called classical, but for me they are. These ARIMA models that you are using previous values to fit in an equation, or if you are modeling volatility, these standard these deviations, you have a Garch model. At the end, they are just calculating parameters of an equation fitting the data.
Mhm.
And that equation predicts the value for the next period. So if you keep doing this iteratively, you have a predicted series. Okay, that's for one series. But if you have more, you have this multivariate time series, also called in economics panel data. And
Mm.
you can, well, economics and social sciences. You can use this as an extension of that previous method. But if you add this stochastic park, you will have a vector autoregression method. Okay, then you are just adding matrices to this. Okay, that's for the classical parts. Well, I want to point out that there are other techniques that come from digital signal processing. Most
Mhm.
of them are using the Fourier transform in order to use a frequency domain. I don't have so much visibility here, but I want to mention it. And this will sound familiar to people with a background in telecommunications or electronics.
Mm.
Okay, now machine learning. The machine learning algorithms could deal with this using previous periods and predicting the next one, like in a regression problem. If you this, you could use the previous values, as a features, as a new features, as new columns, and try to predict the next one. And if you do this iteratively again, you could generate, a new series, and you could have a metric for that, with the similar metrics that we use for a regression problem.
Yes.
The mean square error, the mean absolute error, it's in time series. I think for machine learning they tend to use the symmetric mean absolute percentage error, the SMAP, well, and so on. In my experience, what's working best for um, time series classification or regression, that is in which the series is an easy problem. It's used to be a light gradient boosting method.
Mm.
Adding, with a good feature engineering, like
Mhm.
always, right? Um,
Yes.
just like using the values of the previous periods, plus
Yes.
adding, some statistics, perhaps the mean, the maximum drawdown, which is the difference between the maximum and the minimum. It's mostly used in finance. I don't know, perhaps the skew or something like that. And this could work mostly in classification problems, okay, because
Yes.
time series prediction is quite difficult.
Yeah.
And if you have enough data, if not, it's gonna and a lot of problems don't have enough data. um, Also, perhaps it's worth mentioning that there is a dynamic type wrapping distance. that is a distance that we use to cluster time series, and that's most used when you have, I don't know, a portfolio and you want to make some clusters of the series. You don't use a typical distance because there's different, and you have this dynamic time wrapping because it can deal with different paces. Perhaps we are walking, we have a signal of we walking, and
Hmm.
um, it could take into account that even when you are going faster, perhaps when you
Yes.
are running, it's
Hmm.
different than when you are walking, even when the signal is faster in some sense. Well, it can distinguish some different signals. Okay, so the last part will be neural networks. Okay, here some things. It's supposed that neural networks can do this feature engineering for you, but in my experience, it always helps if you give some statistics, namely what I said before, the mean, the maximum drawdown, the I don't know, the standard deviation, something like that. Yeah, that's all mostly the models.
Wow, thanks. This is a very, very, uh, very.
Too much information,
Um,
right?
no, totally not. I wasn't looking for that detailed of information, but I'm very happy that you break down those two parts and that you shared with you what within your experience worked the best. Like for example, the light gradient boosting model with good feature engineering. So yeah, I feel like feature engineering is key in every model that we're going to develop. And then the section on neural networks, I feel that it gives a lot of values. Like for example, if I'm a guy writing my thesis at the moment with time series, listening to you right now could give me some insights and some ways to like turn around what I'm facing at the moment. So yeah, I think it's perfect. Um, to to go to my follow up questions. So we've talked about all those models, like how they might be implemented, and the metrics for the predictions, which are key. What are the limits of those models based on the type of predictions we want to do? Could you give us more information regarding that?
Yeah, I remember in my masters when I had these time series classes, my teacher told me that that you can say that you can predict a series if you are looking at the series and you have some grasp of what's going to happen. For this easy series, you have these classical statistical models, and they work quite well. You need to do some twerks, some good feature engineering, like using a dummy for the holidays or the weekends or the month. Um, that could work and actually work for this electricity prediction, or some kind of production forecasting. Um, but it's just in those cases, you use this ARIMA, GARCH, ARCH models. But when you are dealing with more chaotic series, the most classic example are financial series, machine learning algorithms were supposed to save the day, but it's harder than than one can think. Machine learning algorithms here are prone to overfit because mostly because we don't have enough data. Um, for a financial series, you have one row per day. This open high low close data you have for points every day.
Mm.
The open value, the high value, the low value, and the close value, and that's like 252 rows per year. And you have 20 years, you will have 5,000 rows. And then you have to split for a train and test data. There's not enough cases or scenarios to be trained with, that the model will be trained with. So it's mostly that. Perhaps if you have, I'm thinking on the financial, perhaps if you have an hourly data or I don't know, minute data, perhaps you could do something. I will say that it could be, but in financial you want to trade, right? You have to you want to earn money. So you also your strategies must be that must have this the same pace, and it's quite difficult because of the commissions, and every problem has its own characteristics. So, well, it's not easy in any case.
All right. Thanks a lot for sharing all those limits of those models. I have a question in mind, and I would like to have your point of view on it. What are the challenges we can face, and some of the solutions regarding time series and what you described previously?
Okay, the solution I was well, we talked that we don't for some problems we don't have enough data, right? And the solution that I was working in the research I was doing was creating synthetic data that will help not just in training but also testing. You have the problem that for financial time series you don't have enough data, right? And we use these GAN architectures, these generative adversarial networks, for creating synthetic series. It was a good idea, but with faces, you can easily see if the model is generated good faces. Um, but with time series, is quite different, as you cannot have this kind of evaluation. You can just look at the series and see they are good or not, because series are not something that with our own eye it's easy to distinguish. And you have other problems that sometimes even the model is generating the same series. Um, this is a state that is known as mode collapse. You want actually for this problem to be good enough to create diverse series, but they, in some sense, they need to come from the same distribution as the training data, um, which is quite weird because you want diverse data, but they need to be from the previous distribution. So if you have wrong data, you won't be able to distinguish from the good synthetic data.
Hmm.
Um, so it was weird. It was like a weird situation. Uh, we trained the models. For us, the acid test was trained a third classifier, usually a ResNet, a deep neural architecture with using residual connections to classify series. So we trained the ResNet without the synthetic new data
Mhm.
and with the synthetic data. So in case if the accuracy is better with the synthetic data, we will say that we will infer that the GAN was creating good series. That was a really good approximation. So that was our way to work this. And you could use this synthetic data for training better and generalize more and so on. But also in the test, because when you are testing a time series classifier or testing this synthetic data, you could you are actually well, let's say for example that you have a strategy a financial strategy to earn money.
Mhm.
So you have some strategy that has a machine learning model, but you are testing only in the test set. Okay, but what happens if the test set that is test distribution is not the distribution that's going to happen in the future? So with
Mm.
the GAN, you can also create more different scenarios for testing. It's like having not just one test set, but multiple test sets. This could give you a better measure if your strategy is going to be good or wrong. In finance, you call it back testing. And
Mhm.
if anyone could want to read about this, Marcos Lopez de Prado, a researcher, talks a lot about this, and I think that could be applied to time series in general, not just financial time series. But I think it's worth read him. Okay, so a lot of changes, challenges. I have not checked the literature in 2 years, I think. Now, with the rise of stable diffusion, this new architecture that's challenging GPT-3 and transformers, I would put money that the latent diffusion models architecture that is being using now could be used also for time series,
Mm.
and I think that there are going to be some changes there. Yep.
All right. I'm not sure I'm familiar with stable diffusion. Could you do a brief introduction, or is it?
I don't have so much visibility. What can I know? What from what I can say is that is an autoencoder at the end
Hmm.
with some twerks
Okay.
and a lot of more steps. You know, when you are actually training an autoencoder, you are trying to get this. You have a really big input layer and a really big end layer, but you are
Mm.
trying to work everything into a small layer in the middle that's trying to get or to infer the latent distribution,
Hmm.
you know, and it's mostly that, but with a few twerks from what I read. And it's been having a lot of attention because it's challenging. This transformers architecture, you know, this big transformer architecture that when you need a lot of GPUs and so on.
Mm.
Um, you know, as I said before, it's different for time series that from generating images.
Yes.
But well, you know, any advance could be great. Well, I'm saying this when every 3 months there is a new architecture that's going to revolutionize the deep learning AI. But well, perhaps not. I think that this could be suitable. The transformers not so much, but this could be suitable to time series.
All right. Okay. Thanks. All right. I would like to do a follow up question regarding this answer. Could you share some time series, like how time series are used today?
Yeah. Um, well, a lot of data has a temporal dependency, like electric production, stock market, value, prices. Almost all IoT data, health signals, hurt, you know. That's mostly in movies, right? And macroeconomic data. Every one of these time series problems has its own characteristics because the frequency of the data, for example, in economics, in macroeconomics, you have 1 point of data for every quarter.
Hmm.
So you actually have not you don't have so much data, but for I don't know electric production, you have a lot of data, and it's not so much. The problem is not so much in the production as in the demand.
Hmm.
Um, Okay, yeah, you know, there is no general. Well, they are. I think they all are trying to. They all have these time series problems, but they also have different ways to approach it. You know, using the models that previously we talk, but you know, sometimes it's like always you have some previous knowledge that could work, and the programmer or the client knows and wants to use about that. Um, Also, it's really good to point out that sometimes the clients don't need the exact value, and you don't need to predict the exact value that you for your problem, but you need, for example, the probability that some value will increase or decrease some percent.
Hmm.
For example, when you are using options, you are not trying to you are not trying to predict the value. You are trying to predict if the price tomorrow is gonna to be um, a 5% more than today or something like that, or in 3 months.
Hmm.
So this could change your regression problem into a classification problem where which is easier. Um, so I will try. A good recommendation perhaps will be that if you can do this, please do that because your accuracies are gonna be higher. Um, what more? No, I think that's that.
All right. Awesome. Thanks. I think we covered a lot the time series part. Before like ending the episode, I still have like two kind of questions I want to ask your point of view on. So the first one is you're so into economics. How do economists approach data?
Yeah, it's gonna be perhaps for a data scientist with a no economics background, it would be weird. Um, in economics, you are not interested so much in prediction. You are interested in causality. Well, I guess that in a lot of other problems, you are interested in causality, but in economics, it's all about that. And traditionally, when there were, you know, you have to think in an economics framework. You don't have so much data, and well, you don't have that much coding background. So traditionally in Econ, you use these data transformations and you add some regressions to fit the data, and then make tests that confirm the data distribution or the error distribution. You are interested mostly in the coefficients. For example, in a linear regression, you are interested in coefficients. In a linear or logistic regression, not in the prediction per se, if the prediction is good or not. Prediction matters, but not so much, because coefficients could give this causality interpretation. They interpretability matters a lot. So, for example, if I'm trying to predict the quantities of the demand, of some product based on prices, or the other way around, I would like to know what coefficient we are predicting, we are calculating, because that's like like the relation, between these two
Mm,
quantities,
mm,
and that actually has an interpretable um, sense, and in which you can say to your client, well, if you increase the price 5%, your revenues are going to increase that much. Or for example, if I um, put a minimum salary, how much people are going to be, how much the unemployment will increase, something like that.
mhm,
Okay, but in the last 20 years, not from economics, but for computer science actually, you have a new field of research named causal inference, where some techniques, mostly they were using DAX, these directed acyclic graphs. If you have used Airflow, you will know what we're talking about, and this is graph where one thing comes before the other.
mhm,
And they are mostly using this, and also some techniques, not they are related to DAX, but not that much. Name, I don't know, difference in difference, relation discontinuity, and so on. um, what they are mostly dealing with the question, what will happen if I do something, and what if not. That's not prediction, that's dealing with the counterfactual. What if.
mhm,
In Econ also, you don't have experiments, you have this kind of quasi experiments. Let's say, what if two regions that are similar, uh, one of them, what if in one of those regions, we do something with the laws. For example, we impose this minimum salary, and not in the other, but
mhm,
they really alike.
mhm,
So we could have this causal measure of what will happen if. Um, and for us data scientists, I think it's quite great that this field is developing, because we can use it for our own questions. For data scientists, it's mostly what will happen if I increase the price or we change the website, and we tend to do this A/B testing. Um, well, perhaps in a it's not A/B testing what economists are doing, but they are namely they are naming these randomized control trials, and they are doing, in Africa. Let's say they give money to some people and not others, and they try to measure this. Those techniques, I think we can that are goes go beyond that, and A/B testing. We actually could use that. Also, that if anyone is interested in this, there are some libraries. We with libraries are we are more comfortable, right? There is this do-why package, and
mhm.
I think this from Microsoft, and the ECOMML. Anyone interested in this could check those packages.
Awesome, thanks. We're running kind of short in time, but I don't care because I have a last question for you before answering the little questions I've prepared for you. I have a last questions. I'm looking forward to your answers. So you are now working with MLOps. Can you explain it more and go through some steps and tools?
Yeah. When I was in my master, 3 or 4 years ago, I think, um, they didn't explain me this much, because, it was the beginning, the rise of the MLOps. And people at the time, you haven't heard about that engineering roles. Like it's 4 years, but it seems like a long time ago because
Mm-hmm.
field that has changed a lot.
Mm-hmm.
Okay, in my research job, my first job, I had to do a lot of experiments, but tracking was horrible. I guess everyone was having the same problems, right? Unless at the beginning of your career, if no one told you that other people were having the same problem.
Mm-hmm.
Okay, at another point, I needed to. Now I think another point of my career, I needed to put a model in production, and solution was quite artisanal. Every time we need a new model, we just add the model in some cloud bucket and update the path. And if you update the path in some table in SQL, well, it's true. No, it's not tricky, but you have to do it in pre-production, then in production, and then in the client. It's not the simplest way.
Mm-hmm.
Now we have solutions for all, I think, for all these problems. What I'm using is MLflow. This is used for experiments tracking, but also for model serving. So you are actually putting some server where you can send all the experiments results, the metrics, the parameters to, and you can also send the model itself in case you want to serve the model, to create an endpoint that could serve predictions.
Mm-hmm.
There are other solutions, namely Kubeflow, which is Kubeflow. Actually, I think is Kubernetes plus Airflow or something like that. But you have from Kubernetes this approximation in pods and containerization.
Mm-hmm.
And also from Airflow, I think it's Airflow, but some Airflow. Some flow must be there, but you have these pipelines and these DAGs where you can put a task for pre-processing, another task for training, another task for model serving. So, a lot of there, I think there is a lot of rise in these kind of tools,
Mm-hmm.
and it's developing quite fast. I think there is actually some overlap between them. Uh, because for model serving you have model serving in Kubeflow and MLflow. I think in TFX, which is the solution for that come from Google and TensorFlow, they are also doing the same. And cloud providers are developing this same thing in their own products. You have this Vertex AI, SageMaker, Azure ML. I think it's quite great because for us data scientists, it's better. At the beginning, we are all in the notebooks, practicing. After that, we go to the scripts, and well, it's a thing you have to. It's good if you know architecture, but sometimes at the beginning we don't want that. We don't actually want to learn that,
Mm-hmm.
unless some of us. And well, now with a cloud solution, it's going to be easier, I think. Um, yeah, if you have worked with Kubernetes, Airflow, and Jenkins, and I know that a lot of people haven't done that because Airflow is mostly for data engineers, and Kubernetes is most for software developers.
Mm-hmm.
But if you have worked with those and you know how they work, uh, learning MLflow and Kubeflow will be quite easy for you. A lot of techniques are similar for this continuous integration or continuous development,
Mm-hmm.
but with some difference, to be suitable for the data science workflow, which is I
Mm-hmm.
think is quite different. Also, the to have a repository where you can download that images, Docker image, and deploy into some container. That's some machine. It's quite good, and we are on the process of that. To monitor, we need to for data scientists in production. The problems are that we need to monitor. We need to have some place where I can save all the models and to
Yes.
make them useful to make predictions. And what happens if to monitor what the model is doing or not, because perhaps the model is useless now, and we are not aware of that. We need to monitor what's the quality of the predictions. It's mostly about that. And I think it's going to change, a lot of things in some years, because right now, Have a lot of demand of data engineers and machine engineers, not so much of data scientists. Because of these kind of things, I think data scientists will need to know how to use these tools. It's gonna be a must in some time, if not now.
Yeah, totally. No, I was very looking forward to hear all those tools that you've been using, as you have different backgrounds and you work on different on all the different parts. So okay, thanks a lot for sharing all of that. Of course, I just want to say to the people who are listening to you, you can always ask me more questions, and maybe we could do another episode with you to like get more in depth or on different points that we've seen on MLOps and all those topics. So feel free to reach out on LinkedIn. Okay, this podcast have come up to an end. I have three last questions. If you could answer them shortly. The first one is: do you have a message that you would like to share regarding AI, or what you've learned, or your vision, the future? Do you have any message?
Yes, mostly for the people that are coming to our field, please learn Git and Docker and do yourself a favor and read the Clean Code book. Um, there's a lot of debate because a lot of people say that it's not good, but I think it's a good starting point for if you approach it with a critical mind to code better.
Hmm.
Makes a difference when you are working with other people and also with clients and so on. And prepare to be learning all your professional life because there's a lot of different problems, different algorithms. I don't know. Every year, there's a new information that you need to be aware. It's completely normal to feel overwhelmed and to have this kind of imposter syndrome. But I can promise you that as time passed, you will feel better. Um, but it's quite normal. Just keep pushing and studying.
Awesome. That's a great motivation message. I needed it. All right. So, how do you keep learning and be curious? Do you have like, so you shared a book, you shared a book, you shared some tools. How do you keep learning? Do you have a tool or a book that helped you on your AI journey? Do you have, do you have something regarding that?
Yeah. At the beginning, when I was studying, I watched a lot of videos from Joshua Starmer in StatQuest. I think he's great.
Yeah, me too.
Yeah. And now I just follow, great minds on Twitter. There's Francois Cholet, LeCun, Jamie Howard, these guys. It's also fun because Francois Cholet has a lot of beefs with other guys. And also, I follow people on LinkedIn. I think the most important, perhaps, or that everyone should follow is Chip Huyen for MLOps. And it's mostly that. I think um, you need to have fun, perhaps do
Mhm.
something that's not on that that's out of your circle. Perhaps I know if you know nothing about web scrapping, try to use something right about that. The beautiful soup, scrappy. From every now and then, I think it's a good um, it's a good thing to do something that you don't feel comfortable and to learn. We are here just to learn how to make things, right? So that's, for me, it's a really good advice.
Awesome. Thanks a lot. Just Chip Huyen. It's CHIP space HUYEN. If anyone was looking to follow someone that talks a lot about MLOps and follow this recommendation. I will also write all those down in the newsletter. So I recommend you to check the newsletter on LinkedIn, Thomas Bustos. We've come to an end. I want to thank you a lot for your time first and all this knowledge that you take time to share. And I really enjoy listening every steps from the time series to the economics approach, the A/B tasting, and like the new ways you've mentioned to the MLOps, machine learning operations. where we've went deeper. So I wanted to thank you. Do you have recommendation of two people that would come on the podcast?
Yeah, I would like, I had a partner, one partner, I was studying with a peer, Alejandro Vaca. He's a really good data scientist. Actually, he's been in research since we left the master, and he's a kind of a great guy because he's obsessed with this. He enjoys a lot. I think every listener perhaps knows someone that enjoys a lot to be here, and he's spending like weekends or he's talking every time about this. Yeah, he's that kind of guy. Um, and he was working in the implementation in Spanish for BERT, so they were working a lot in his company. And well, also Lenny Razabal, who is a candidate, PhD candidate in law, and she's writing a lot of the wrongs on the European regulation on AI and how that affects innovation, and well, how the I think it's a global problem, right? Every jurisdictional sector it's like more traditional, and perhaps in Estonia it's not that way, but at least in Spain, I'm guessing also that in in English countries they have the same problem. But yeah, I would like to I love to you hear those podcasts.
Awesome. Well, thanks a lot. Thanks a lot again for all the episode. I know it took a little bit longer than the time format I would like to maintain, but I really looked forward hearing all your answers. So I don't really care about the time. And if you're still here, well, thanks for making it with us until the end of the podcast. And I'll see you on the next one. And have a good day, Gustavo. Thanks again.
Okay,